Welcome to the masterclass on PydanticAI, a new framework for building AI agents. In this masterclass, we're learning about the core features of PydanticAI and how to build effective agents using simple Python code. We aim to hit all key features of the framework with plenty of examples, so by the end of this, you have the confidence and knowledge to build your own agents. Today, we're taking a detailed look at how to make your agents remember previous messages through short and long-term memory. In PydanticAI, agent memory is supplied through the message history parameter during agent runtime. This makes it quite simple to pass any list of formatted messages before executing the agent. But before we dig deeper, let's examine what agent memory is, why it is important, and the types of agent memory. Now, when you consider the typical interaction with users and LLMs, you think of the agent as the central piece, and that's quite right. The user makes a request, and the agent then uses a couple of constructs to add context to its execution. Those constructs are system and user prompts, memory, and tools. And tools include access to data sources such as RAG, vector stores, file systems, you name it, API calls. But memory here plays a central role. And memory is a collection of messages that were executed throughout the session or loaded from the disk from previous sessions. If you've used ChatGPT or other popular frameworks, you will recognize the chat history on the left. You can click on any one of those threads and it will load the entire chat history. So that chat history or portion of it is passed to the agent for additional context. This creates for a richer understanding of the conversation and remembering of key details supplied by the user. It's really essential, and that's why I'm so excited about this module today. There are two types of memory, long-term and short-term. Short-term memory is only available throughout the session where the user is interacting with the agent, and it's ephemeral and it basically goes away as soon as the session is closed. Long-term memory, on the other hand, is persisted on a disk. It can be saved in a file system, as we'll see in one of our extended examples, or onto a database. Other frameworks provide different mechanisms for storing messages. For example, in LangChain LangGraph, you have thread ID, which is a construct that helps you identify various threads. In PydanticAI, there is no such construct, but you have the freedom to persist messages any way you like. So it's quite simple to put them in a database table or onto the file system, or just serialize them with a plain Python library such as Pickle. And that's the method that we're going to take in one of our persistence examples. All right, let's move on. Now, memory in PydanticAI, as I mentioned, is a simple list, and the parameter that is being passed is message underscore history. The list is composed of model message type of messages, and model message has two subclasses. One is model request, the other one is model response. A lot of the user requests or tool requests will be in the category of model request, and the model response will be the responses from the model or other constructs that come with the ecosystem. To think of this in simple terms as when the user supplies a message, that's a model request. When the model responds, that's a model response. That's the type of messages stored in this list. And this becomes very important because, as we'll see in the fourth example, I'll show you how to filter these messages when passing them into the LLM. It's not always a great idea to pass the entire list of messages, the entire context of the history of the conversation. Sometimes these conversations become too long and too irrelevant. It's also common for users to switch the conversation midway through. They would start a thread, for example, as a marketing research, and midway through they would turn the thread into stock market research. And the first half of the conversation then becomes irrelevant, not only irrelevant, but also noise for the LLM. So it's important for us as developers to filter out the relevant messages and only pass perhaps a section of this list to the LLM and not the entire list. I'll show you that in one of the examples, how to make the list pass to the LLM a lot shorter, a lot more effective, and therefore increasing the effectiveness of the answers that are coming from the LLM. All right, let's move on. Before we move forward to the coding examples, I'd like to tell you a little bit about the new school community that I've started. It's an exclusive community that provides a classroom with all the extended examples and source resources for all the masterclass modules for PydanticAI. In addition to this, we have weekly meetings. So in the calendar section, you'll see that we have strategy meetings where each member can ask their questions, and it's a very lively discussion. And it's a really great way to get into learning PydanticAI, get one-on-one with me to get all of your questions answered in a timely manner. I'd recommend you take a look at the school. The link will be in the video description, and I hope to see you there. Today, we'll work on 6 examples, starting with the hello world, then we'll move on to more complex examples. To keep the video concise, we'll cover the first example in full detail, while the rest will be available in the extended version. In the first example, we'll look into an agent network for portfolio investment advice. Now, this is going to be a really interesting example, and it will cover kind of most of the concepts around agent memory. We'll have 2 agents that will be GPT-4o mini agents that will argue for and against purchasing of a particular stock. In our first example, we'll pass NVIDIA and then we'll switch to Tesla, and we'll see what our agents will come up with as far as the research and their advice. Then we'll combine those 2 messages and pass them on to a reasoning agent. And for this, I'm going to use my local DeepSeek R1 that will take the messages from these previous 2 agents and put into a reasoning answer and give us a final yes or no or a portfolio allocation. I will specifically put some guardrails, because if you go too wide in these question and answers, be it as a regular GPT agent or a reasoning agent. For example, if the question is simply, should I buy Tesla or should I buy NVIDIA? The results are not that great. You need to put a lot of restrictions onto the model, and I'll show you in the system prompt the restrictions that I have put in place in specifics to the model so it can actually get to a better decision-making process. The more details, the more specifics in the question, in the prompt, the better the outputs from the LLM are going to be. The wider the question, the more vague the answers, the more generic the answers, and more useless at the end of the day the answers will be. Next, we'll look into a full memory examples, exploring how the memory will work if we pass the entire history. And that's where I'll show you how to filter the last n number of messages instead of passing the entire memory history. It's really important, and it will change from application to application. So you need to listen carefully and apply these learnings into your model, into your domain, into your use case. Be the judge what makes sense for your use case. I used the example number 5, so the last 5 messages. For some domains, say such as a medical domain, if you would like to get the entire history of the conversation, diagnosis, and lab results, and so on and so forth for a particular case, you may want to extend that to maybe 50 or 100. But I'll just give you the tools and show you how to do that in PydanticAI, so that at the end of the day, you get a lot more focused answers from the LLMs. In the third example, I'll show you how to filter messages based on model request or model response. This is another technique where you can take the entire list, and instead of passing the entire list, you will just pass a filtered version. Next, this is super cool. I'll show you how to persist memory. And we'll use Pickle, and we'll just use standard Python serialization, deserialization. Our entire message history conversation will be serialized to the disk in a .pickle, and then it will be read there next time we'll launch our agent. This is a very simple technique, but you can extend this and make that a database persistence. The last 2 examples are also going to be very interesting. I'll show you how to do a multi-agent network where each agent can pass its memory to the next agent. Super cool. PydanticAI is unique in that way from other frameworks. In other frameworks, usually you kind of restricted by the agent, but here it's a simple list and you can pass it around as you wish. So it's a really, really cool way to share memory among agents and construct multi-agent networks with a shared memory. So super cool. And the very last example will be an extension of our first example, but this time we'll do a variation. Instead of a stock portfolio investment advice, we'll get a marketing advice, and we'll ask our agents to debate the pros and cons of running a marketing campaign for a President's Day sale. And then our reasoning agent will put the cap on the discussion, and it will tell us whether it's a good idea or a bad idea, or what are some of the pitfalls we should avoid. So really, really good agenda today. Let's get started with our first example. In this Hello World example, we'll start by importing our libraries, standard stuff from OS. We're going to get our environment variables, obviously. From Colorama, we'll get some color for our terminal. From PydanticAI, we'll use agent. That's the only thing that we need. And since they changed the model, we no longer need any Ollama models or anything. We'll just use the OpenAI model, which we'll also use for our local Ollama model. So really, really cool stuff. PydanticAI simplified it in their .22 release. We're going to define two models here. Just take a look at lines 11 and 12. The first one will be the OpenAI GPT-4o Mini, and the second one will be our DeepSeek R1 running on my local Ollama server with that URL and port. Just as a reminder, I'm on a MacBook Pro M3 with 16 gigabytes of shared RAM. The maximum I can use locally on my laptop is the 7 and 8 billion parameter models. So that's what I'm using, DeepSeek R1 7 billion. If you have a GPU, or if you'd like to use a larger model, feel free to change these models and use something like Grok, for example, which will give you almost free access to the DeepSeek R1 70 billion parameter model. Super cool. I'll put links in the video description if you'd like to get access to the Grok models and use them for free with DeepSeek. But for me, this setup works and it's reasonably good output, so I'll continue using that. So now our first stock will be NVIDIA. I'll just put it as a constant, and I'll pause here after the system prompt is finished. So I'd like to pull your attention onto the system prompt, and as I mentioned, it is so important to have a descriptive system prompt. I cannot underscore more how important it is to have a descriptive and restrictive so that the model knows what to produce. For example, if you just go ahead and ask, which one is better, NVIDIA or Tesla? The model gets confused. It does not know based on what criteria to put this information together. It's referring to its training data, and it will give you a rather random advice. However, here's our system prompt. You are an investment portfolio manager specialized in US tech stocks. So immediately US tech stocks. So I just excluded 90% of the market, right? Next, the user is a 45-year-old tech executive. What does tech executive mean? It means that this person is familiar with the tech industry, so he is also preferentially wants to invest in tech stocks with a net worth of 10 million US and a 5-year aggressive investment window. So this is not a person who is looking for safe investments and long-term retirement planning. This is super important also. So these are the guardrails. These are the parameters, restrictions that are needed for the LLM. Your job is to provide investment advice on stock passed as a parameter so that you can change it later. The user will never invest more than 5% of their portfolio to any individual stock or ETF. Again, an important piece of information, because if you don't supply this, then the model sometimes will go into these loops and tell you to invest $10 million into Tesla stock, which obviously may or may not be a great decision. For my investment style, that would be a really bad decision. However, maximum 5% 10% guardrail, then the model knows what the allocation should be. Next, your job is to guide the decision and support a number between 1% to 5%. Consider the user's profile, investment window, so on and so forth. So a super important system prompt. Let's continue now. We're going to define our first agent taking the system prompt. We're going to define our reasoning agent also taking the system prompt. And we're going to pass the messages along the way during runtime. So the messages right now will get the all messages from the pro agent. And there are two ways to get messages here. You can get new underscore messages or all messages. New messages will get just the last batch of messages. Usually it's two. So the model request and the model response will be part of the new messages return type. All messages will get the entire conversation history. Usually, rule of thumb, I'm a big fan of using new messages. I take new messages and construct my list and pass that manually as opposed to getting all messages and dealing with a large stack of messages. But it's just a personal preference. I find dealing with new messages easier and constructing and expanding my list with the new messages easier than dealing with all messages. All right, the pro user, the result pro will provide arguments why I should buy stock and how much I should invest. The con argument will be counter arguments why I should not buy stock and what to do instead. And those are the debate questions here. The reasoning agent will respond, well, should I buy the stock? Respond with yes or no. So we need a definitive answer, yes or no. And then provide some alternatives. Again, a very descriptive system prompt. By the way, just a small parenthesis here. If you ever struggle to write descriptive system prompts, you can also use ChatGPT or any other AI to just get the prompt. And sometimes ChatGPT is able to come up with a very descriptive system prompt, which you can then plug into your agent network. All right, let's continue. Now we can open a terminal and execute our script and see what our investment portfolio agents will provide as a guidance. First that will kick in will be the pro agent. And now the GPT-4o mini is thinking about the NVIDIA stock as well as combining that with the system prompt that I just supplied. Okay, so we have our initial set of pros and we're going to continue now. We see that the execution still continues, but we can just read this a little bit. Now the con agent has concluded as well, so we print that in red and we're going to wait for our final agent. So let's take a look at this whole execution. Let's start from the top and look at what the allocation is. So we see that considering the profile, it obviously considered the system prompt. And let's see what the investing 4% of your portfolio in NVIDIA is the recommendation of the pro agent. Now, we can also see that the con agent is making arguments against, including some of the weaknesses of the NVIDIA stock, the market, some of the trade tariffs and incoming challenges and risks in the market space. Those are really, really important. And both of these messages now are passed on to our reasoning agent. And the reasoning agent goes through a set of thinking steps. And so let's see, it's provided this information, it's considering all these steps, and in summary, it's giving us a yes to buy the stock. There are certain caveats that we should consider, and we can see that there's quite a bit of detail in this answer, but overall, this is a very, very good position that the reasoning agent is considering both messages that were passed, the pro and con, and is able to provide that advice. Now let's go back and change our stock to Tesla and run it one more time. And this time the recommendation is 5% allocation to Tesla stock. We're going to get our con agent against investing. And here is our reasoning agent outputs as well. So the con agent recommended 3%, and here's our reasoning agent. And the reasoning agent took both messages and provided that final decision is yes, you should consider buying Tesla. as part of your portfolio, and it recommended 5%. So you never know how it's going to turn out. I have had examples where the pro agent recommended 5%, the con agent dropped it to 3%, and then the reasoning agent took the average and said 4% is probably a reasonable way to go. But in this case, the reasoning agent took the pro agent's recommendation and took it at full 5% recommendation. But that's still really good because it did consider the pro and con of this question. It did consider all the facts. The messages is what made the difference. The messages is what we passed to the DeepSeek R1. And those were the messages from our previous two agents. Remember, in the messages list, you can pass any data, any information. It doesn't necessarily have to be user supplied or model supplied. You can get it from an API call and pass it as a message. You can get it from a tool and pass it as a message. You can pass a additional system prompt as a message. System prompts and user prompts are also messages in this list. So it's a very flexible way to modify and shape our conversation. So just keep in mind that it's a very important tool that you can use to your advantage to make more effective agents. All right, let's move on. Short and long-term memory provides two ways in which agents can gain additional context by using previous messages. This is super important. Along with prompts, system prompts, user prompts, and tools, memory provides an amazing construct for agents to become more effective. Now, PydanticAI takes the simple approach. Different than other frameworks where you have memory as special classes and you have memory persistence as special methods, PydanticAI simplifies that, and it's just a message history parameter passed at runtime. You can pass this and you can make it possible for agents to use both short and long-term memory. In this tutorial, I showed you examples of how to use full memory, how to trim the memory, how to filter messages based on type or any particular feature of the message, and I showed you how to persist messages. In the last two examples, I also showed you how to share messages between multiple agents, and we did a variation of our sparring agents from our Hello World example. I hope that you enjoyed this. Next time, we'll look into ways of how to create more resilient agents through graceful handling of model errors in PydanticAI. But for today, this is a wrap. I really hope that you enjoyed this tutorial because I had a lot of fun making it, and I hope that your agents will become more effective through agent memory. If you get value from this series, please consider subscribing and giving this video a thumbs up. Thank you, and see you in the next one.